Good day, students. In this clip, we're going to be going over the process of solving formulas for specified variables. This can really come in handy when you're working with some really complicated equations in higher level mathematics, all right? So we're going to be dealing with some basic geometry formulas today, and also some formulas involving analytic geometry, all right? So let's start out with question number one. Oh, well, let's write down the instructions first. So solve the given formulas. Solve the given formulas for the specified variables. Specified variables. Okay. All right. Number one. So let's say we have n equals y2 minus y1 over x2 minus x1. And the indicated variable that we are supposed to solve for here is y1. Okay? Alright, so the goal here is we're going to isolate y1. So basically we need everything else moved to the other side and we need y1 alone. Alright, so we have n equals y2 minus y1 divided by x2 minus x1. I'm going to eliminate the denominator as a package, okay, since they're both united by negative. To move them, since they're being divided by the numerator, I can group them like this, and I can move them to the other side as a package, alright? So what I'll do is simply multiply by the reciprocal of that. Since this is in the denominator, I'm just going to multiply by x2 minus x1 over 1 on the left side, and then times x2 minus x1, like that, alright? The reason I have this in the numerator is because this two cancel out. This goes into itself once, and that goes into itself once. And then you have this expression right here. I can put the m first. M times x2 minus x1 equals y2 minus y1. Okay? So the goal is to isolate y1. So I need to get rid of this y2 right here. So to do that, I'll just subtract y2 from both sides. So that will give me m times x2 minus x1. So x2 minus x1 minus y2 equals negative y1. Alright? So finally, to get rid of this minus right here, I can multiply both sides by negative. So I'll multiply negative y1 by negative 1, and I'll multiply this whole expression right here by negative 1. Okay? Because I know minus times minus is positive, and that'll get rid of the minus on the right side. So if I distribute it, I have negative m times x2 minus x1. And then when you distribute this minus to this minus right here, it becomes plus y2 equals y1. Okay? So using the reflexive property of equality, I can switch this equation around. I'll have y1 equals, now since y2 is positive, I can write it first, y2 minus m x2 minus x1. Okay? So there you have it. That's my answer. Alright, we're going to move on to the next example. Example number 2. What if we had the following equation? A squared plus b squared equals c squared. And in this problem, we asked to solve for b. Now, what equation is this? This is the Pythagorean formula. Pythagorean equation or formula. Right? So we're going to get b squared by itself. Let me rewrite the problem down here. A squared plus b squared equals c squared. So first thing I'll do is I'll subtract a squared from both sides. And then I'll have b squared equals c squared minus a squared. And then finally, to get b isolated, I'll take the square root of both sides. So I'll root the left side, and I'll root the right side. And then I'm going to have b equals plus or minus the square root of c squared minus a squared. Now, if this were constrained just to the lengths, the sides of a rectangle, if they're actually side lengths, then our answer will be b equals the square root of c squared minus a squared, because length can never be negative. All right, so this is the answer if it was just these were just any variables. But if it were constrained to a triangle, then this would be the answer. This is just for length. All right, if it were length, then this is the only possible answer. All right, so any one of these will work. This is for this general solution. This is specified, applies only to a rectangle or a length scenario. All right, let's move on to another formula. Formula number 3. What if we have the formula A equals 1/2 height times base 1 plus base 2. This is the formula for the area of a trapezoid. All right, so this problem wants us to solve for B1. Okay. Now to solve for B1, this is our approach. We're going to get rid of the 1/2 and then the h, probably together, and then we get rid of the B2. All right, so let's rewrite the problem. A equals 1/2 h B1 plus B2. So to get rid of the 1/2 h, I can multiply both sides by the reciprocal of that. 1/2 h is like h over 2. So since we have 1 over 2, we're going to have 2 over 1. And since the h is upstairs, we're going to bring it downstairs over here, okay? So the same thing here. I'm going to multiply it by 2 over 1 to get rid of the 2, and then 1 over h. That gets rid of the h on the right side, okay? So what is cancellation? See this 2 right here reduces with that to 1. And then this h upstairs here reduces with this h. It's as though there was a 1 under that h there, okay? So they have it all reduced out. On the left side, if we multiply everything together, let's put a 1 under the a. So we're going to have 2a over 2h equals b1 plus b2. I can drop the parentheses because I have nothing in front anymore, just 1, and the 1 does not do anything, okay, when multiplying. It's a multiplicative identity. So to finish this off and isolate b1, I just subtract b2 from both sides, subtract b2, subtract b2. And my final answer, b1, is going to be 2a over 2h minus b2. Okay? So there goes the formula with b1, which is one of the bases, isolated. Alright, let's move on to another equation, or actually another formula. Number 4. What if we had this formula? Ooh, I kind of jumped ahead of myself. Number 4, what if we had the formula A equals pi r squared, and we asked to solve for r. Okay? And what formula is this? This is the formula for the area of a circle. So this is not too complicated. Pi r squared. Now to get r by itself, I need to get rid of the pi, the coefficient, and then the square. To get rid of the pi, I divide both sides by pi. And then I'm going to have a over pi equals r squared. And then to finish this up, I'll take the square root of both sides, square root of that, square root of this. And then the answer is going to be, we're going to have r equals the square root of a over pi. Okay? This is a radius, so we don't have to do plus or minus here. So this can be simplified further. This answer is good, but it can be simplified further, because sometimes you might not be permitted to have a fraction under a square root as a radicand. So if I wanted to simplify this further, the square root of a over pi, sorry, I'll break up the square root into square root of a divided by square root of pi. Then I'll rationalize the denominator by multiplying by square root of pi top and bottom. And then that's going to give me the square root of a pi divided by square root of pi times square root of pi is simply pi, like that. Okay, so this is the answer in completely simplified form. Okay, because either this is not completely simplified, this is an acceptable answer, but this is completely simplified. Alright, so that's that. Alright, so thank you so much for watching this presentation. Please feel free to subscribe to my videos and share with your friends. More math videos can be found on mathgoserve.com. Thanks again and have a wonderful day.